ES 2015 Plus allow us to implement the singleton pattern to create global instance of a JavaScript class that is instantiated once. You can expose the singleton instance through a module export. So it's the same with other methods and modules. This is just more a nuanced take of creating a global instance that you would reference to if it already exists on the system. This makes access to it more explicit and controlled. So with the modern JavaScript, this creation of this instance also take advantage of the export. So notice how the private and the everything went back to those private and public concepts, and then to those closure concepts where you keep the state at a minimum, because you're actually basically controlling its state leaks or complexity. This is also differentiates it from other global variables. So another benefit, it took advantage just as you would with module export, is it differentiate it with other module export in the system. But in this case, it is differentiating itself with global variables. And then you still need to keep in mind how your namespace globally affect each other, which we're gonna discuss in the future topics. You cannot create a new class instance, but can read or modify the instance using public get and set methods defined in the class. Another thing is that, as you can see, it used the principle of the get set methods of the constructor object pattern. So that get set and set methods are also more of a newer take or newer techniques in JavaScript. Okay, so also notice how the instantiation is what is being restricted here compared to other concepts such as variable edits, right? So that we discussed. Here, you cannot instantiate a new class, but you can read or modify that instance already in the public if you are allowed by the global rules. Like for example, the user are logged in or logged out. We can implement singleton as follows. So the pattern instance stores a reference to the singleton let instance semicolon. So that's we didn't provide any value. So it's another way, like in Python, when you're defining something, you can not define any value for that variable. So here is the case for, or here is the pattern for that singleton instance. So private methods and variables. So const private method equal open and close parentheses arrow function inside this console log that I am private, and then next line const private variable equal string I'm also private, and then closing, and then next line const random equal math dot random function, then closing. Singleton, here we are now creating a singleton after we have created the variable and the constant. And remember, those constant could be an object that could be mutated in runtime. So here we created the class mySingleton. Get the singleton instance if one exists, or create one if it doesn't. So here we use a constructor. So we basically use the constructor, not just the get and set method of that constructor to modify and read it, but also the actual function. So here constructor function inside is, So inside the class is a constructor function. Inside constructor is an if else statement. So if not instance, then public property this that public property equal I'm also public string, and then next line instance equals to this, then closing, and then if not or else return instance closing. Now this is the public methods. The um, public method function inside this console.log, and then next line get random number, return random number, and then default export module without name, export default my singleton. So now we're exporting this class, the my singleton. So instance stores a reference to the ton, let instance, and then a singleton again, class my bad. So it's the same, it's all in the same module. We're not going into other module. Class my bad singleton, and then we have a constructor function. Inside constructor function, we have this that random equal mat that random function. So we use the random function inside of that class that we defined earlier, the class my singleton, and the next line instant equals this. Again, this is how we define like an object, a method, or to this is how we avoid like using the actual object name and dot operator and the method to be able to access a method. So this is a shortcut way to access the method of the object. So this dot random equal mat dot random, then instance equal this, then return instance. So it doesn't have if else now. It just used the this to access the value from the previous class, and then closing. Then it has get random function as well, and then inside it return this dot random number, then closure, and then export default my singleton. So to use this, we import my singleton from dot slash my singleton, and then import my bad singleton from dot slash my bad singleton. Hold on, let me see. Yeah. So basically, we import it via class instead of like a module. So here we create a constant again. So this my singleton, just like with the constructor and other patterns we saw, like use a variable, declaration and constant variable at the top for the child, or rather down class or functions, to be able to use those value. I mean, or to be able to reference those value inside this module. So that's kind of a pattern of this singleton, and with other things as well. We mostly use this pattern. So here we also do that. After we import, we define a constant, single a equal new my singleton class or object, then closing. The next line const single b equal new my singleton. The next line console.log single a, which is the one we instantiate as a constant or object, single a that get random number function, and then we equate that equal single b that get random. Then here we have my bad single a equal new my bad singleton, then const bad single b. So it's the same, and then we console.log bad single a that get random not equal bad single a. So true. So as you can see here, this console like just equate them. As you can see, they are both true. It's just to tell you that those instances are the same. It didn't create new instance because of this pattern of this class. It's singleton. If it's already exists, it will only reference those things that exist. If it doesn't, then that's the time it will instantiate it. So you can see we instantiated 2, but it doesn't actually instantiate 2. It actually equate it, because using those class has a method inside it that check if the instance is already created. It will not create it. Note, as we are working with random numbers, there's a mathematical possibility both numbers will be the same. However, unlikely. The preceding example should otherwise still be valid. So this is how the basics of singleton works. What makes singleton is the global access to the instance. The Goff book describes the applicability of the singleton pattern as follows. There must be exactly one instance of a class, and it must be accessible to clients from a well-known access points. So it must be accessible, kind of like with the global thing. Or with this type of example, it was accessible by importing it, um, importing the class, because again we export that class from, those two class from one module. The sole instance should be extensible by subclassing and it must be accessible to clients. The sole instance should be extensible by subclassing, and clients should be able to use an extended instance without modifying their code. So another property of this, aside from being able to read or modify those instance if it already exists, is that this instance is a class. Okay, as we saw, we have two class. Those two instance must be extensible by other classes or by subclassing. So it must be extensible by other module. Of course, that's the related to the first point of being able to access it. And the client should be able to use an extended instance without modifying their code. So they must be able to use or import that exported class without actually changing that module code or the implementation of that subclassing. Okay, so the second of this point refers to a case where we might need codes such as this, like constructor object. So inside this is if this dot instance equal null, then inside this if is full, and then inside this dot instance equal new foo singleton, and then closure, else this dot instance equal new basic singleton, return this dot slash instance. So these are the more elaborate way to explain that second point. Here the constructor becomes a little like a factory method, and we don't need to update each point in our code accessing it. So it also relate with the factory method, which we will discuss like later. Um, we don't need to update each point in our code accessing it. So to be able to like access this dot instance constructor, we don't need to update anything on our code. Foo singleton in this example would be a subclass of basic singleton and implement the same interface. So this foo singleton like implement the same so this if else inside of this if of constructor are actually a subclass. So the second or the else that we created here as a new object, the basic singleton, where uh, its subclass is actually the first if, which is the foo singleton. So why is deferring execution considered significant for singleton? In C++, it serves as isolation from the unpredictability of dynamic initialization order, returning control to the programmer. So basically, it cares about the unpredictability of the order. another thing or its properties is that it deferred execution. As you can see, singleton is complicated because a lot of properties define it. It doesn't just define those simple class, but it also define the order in which you will access it. So what deferring execution means? Deferring execution means don't create the singleton immediately when the program starts. Create it only when it is first needed. So that's what it is. So basically, once your application was loaded, it doesn't necessarily need to instantiate that singleton. So it kind of like a dynamic import or dynamic loading. Instead of my singleton global instance semicolon created at program startup, you do my singleton and get instance function. Inside this function, static my singleton instance closure return instance, then closing. This is called lazy initialization. Second, why this matters in C++. C++ is something called the static initialization order fiasco. When you have global objects across multiple files, like here, file a.cpp, my logger, closing, then file b.cpp, database db, argument logger, closing. The C++ standard does not guarantee which global objects gets constructed first across translation units. So, one of the things related with this is the global namespace pollution or global object pollution. So when you have global objects across multiple files like this, so the C++ standard, because it's related to the OS, does not guarantee which switch gets constructed first, because it relates to the OS how it would like initiate it, right? So maybe logger is created first, maybe db is created first. You have no idea. That's the reason why you need to have like strict contract that you would initiate only that singleton when it actually needed. If db depends on logger but logger isn't constructed yet, you get undefined behavior or error in runtime, right? So basically you have those dependencies that aren't actually in the runtime. So it's kind of like with the JavaScript, where the types are only the type error only discovered in runtime. You don't want to do that. That's what the book means by unpredictability of um, dynamic initialization order, and that's by design, and why deferring execution is significant for singleton. Like you can choose not to defer the execution, but you're gonna get a lot of these runtime bugs in your code when you actually run it. How deferring execution fixes this? When you use mylogger and getLogger function, and then inside static mylogger instance, then return instance and closing. Now the object is created only when getLogger is called. Constructions happen in a well-defined moment. Order becomes controlled by function call order, not file load order. So you differentiate it, the loading of it, instead of the file. Yeah, you would load the file when the application gets into the user space, but it doesn't necessarily need to instantiate that object. So it now, I mean, it is not actually that files are not, because files and object are different. File is like a dead program. So you would not like put that program in and then make it alive as a process uh, for like a structured initialization. You would only call that program uh, if someone calls it. So it's controlled by another way of saying is just controlled by function call order. So instead of the compiler deciding order, the programmer decides order. So instead of the compiler, like because you, I mean most programming language compile in in their like language to AST, or in a tree data structure which remove like space, anything unnecessary, and then convert it to bytecode, and then that bytecode um, will then let me see. And then that bytecode is evaluated by runtime, kind of like how you pipe command line before with Unix. So basically, you get the value, you execute, you compile that bytecode first, and then you pass it to another program which is a runtime that evaluate that bytecode. So in this case, those steps of compile time doesn't decide how those singleton class will be evaluated. That's another property of it that makes it complicated. So instead of compiler deciding order, the programmer decides order, or your code decides order. So depending on your how you write code and how it is being converted from AST to bytecode to runtime, those the code that you've written will now decide if it will be instantiated or not. That's why uh, it's significant for that singleton for to implement those in your code. Okay, it is not being enforced in compile time. So as an application developer, you must do it yourself. So that's what the sentence means, returning control to the programmer. You control when initialization happens. Why this is significant for a singleton? A singleton is usually a logger, a configuration object, a database connection pool, a global state manager, like Redux. These this database connection pool are also written in TypeScript. So this TypeScript code, you would implement this like strictly if instance or if else instance, and then you would only load that if the application actually needs to connect to a database. Okay, so you don't fuck this dynamic ordering, or you don't mess up this dynamic initialization order. And also it's a configuration object, so you would only need the configuration if you actually do it, whether it's in local environment, whether it's in production, or whether it's in testing environment. So this often depend on other systems. So those are dependent on other systems call or function call. If constructed too early, dependencies may not exist, or the user doesn't actually like need a connection to database, but you instantiate that object already. Configuration may not be loaded, so that configuration for for example for local may not actually needed because you're in production. Environment may not be ready. Lazy initialization guarantees the system is initialized only when actually needed. That makes singleton safer. Fifth, how this connects back to the module pattern. In JavaScript, modules execute immediately when imported. but const db equal new database, open and equals new database object, then closing, then export default db. This runs at import time. If another module depends on something not yet initialized, similar conceptual risk. So the issue with module pattern we discussed is that it actually immediately execute those imported, or it immediately convert those code to bytecode and runtime if that import is at the top of the code. Like when you create that const db equals new object and then export it, so those code, despite not anyone using it, will be converted, and that object will be available on runtime, or that program will come alive as a process. So if another module depends on something not yet initialized, similar conceptual risk. So even if it's not a singleton, even if it's just a module, and on that module depends on something not yet initialized, you get this conceptual risk as well of having like a runtime error. So in modern systems, we often defer it. So like let db semicolon export function get db object, and then inside it, if not db, then inside is a db equal new database object, and then closing, then return db. That's lazy singleton creation. Same idea as C++, just different language mechanics. 6. The deeper architectural idea. This is about determinism in system initialization. In small programs, you don't notice this. In large systems, order of initialization, side effects during import, global state timing. These cause production bugs that are extremely hard to debug. Lazy singleton gives you predictable construction, control dependency order. So these side effects, just like with hooks in React, where you would put the side effects under the commit, after the commit, is also related here, though it might not be as obvious at first glance. So this actually, because you defer the instantiation, you control those side effects or dependency order, like the dependency that might otherwise not yet instantiated. Isolation from startup chaos. So you get those startup chaos less when you do this. Why is this conceptually advanced? This is no longer pattern memorization. This is about program lifetime, object life cycle, dependency management. So it's also like state management, right? So object life cycle and state management is related, because a class is inherently an object. So when you manage the state of a class, you're managing object life cycle. Dependency management related to dependency injection with properties of most programming language. The deterministic bootstrapping. This is the kind of thinking you see in Owen's design, game engines, database engines, high-frequency trading systems. Simple mental model, think of it like this. Immediate singleton, build the power plant before knowing the city needs electricity. Deferred singleton, build the power plant when the first house turns on light. The seconds give you control. It's essential to know the difference between a static instance of a class object and a singleton. While you can implement a singleton as a static instance, it can be constructed lazily. So another thing is that It's just reiterating the static and dynamic loading of it. So the static instance does not, I mean, of a class and a singleton. So that's the difference basically. A static instance imported upon the module, upon load of program to the user space. Well, you can implement a singleton as a static instance. It doesn't mean that singleton is the same as static instance, right? Because singleton can also be loaded lazily like dynamic import. That's what it means, which is often the case in most app, which is often the use of this singleton pattern. Like if you use like a static instance for singleton, you're gonna get an error on your app and you won't be able to use it. Suppose we have a static object that we can initialize directly. In this case, we need to ensure the code isn't always executed in the same order, i.e. in case obj_car needs obj_will during its initialization, and this doesn't scale when you have a large number of source files as discussed earlier, which is one of its trade-offs worth reiterating. So because like a static, the disadvantage of static importing is actually it doesn't follow the structure order of its dependencies. It's worth reiterating the trade-offs that you would get in a static order. Though your app may load faster, some of the parts of the app may load faster, does that doesn't necessarily mean that it is the right, it will execute these dependencies in the right order. Because again, dynamic initialization is more designed for that. Both singleton and static objects are useful but shouldn't be overused. The same way we shouldn't overuse other patterns. So these are useful but it shouldn't be overused either. In practice, it helps us to use the singleton pattern when exactly one object is needed to coordinate others across a system. So that's another of its properties is that aside from it is related to factory pattern, it is created using the creating variable in class, is that this object is actually coordinating a lot of things inside of our application. So therefore, you wouldn't want to instantiate this at load time of the file or from program to user space without what's this without those global coordination or dependencies actually were important. So the following is one example exactly that uses the pattern in this context. So here we create a class singleton instead of just variable or constants. Then inside is a constructor object with a parameter options with an argument options is equal to empty array, and then inside of this object we use this dot name is equal singleton tester, then closing, and then this dot point x equal options dot point x or 6, which is a JavaScript way of saying that if this option dot point x does not exist, you would use 6 and then closing, and then this dot point y equal option dot point y or 10 and then closing of this constructor. Now in our instance holder, so now we create the variable let instance. Notice like the holder of that singleton is a variable, or we use that for JavaScript. Then sa const object inside we define a key value name and then singleton tester string comma, and then after that key value we define a method for getting an instance. It returns a singleton instance of a single object. So this is kind of like the get and set method. So get instance argument options. Inside it is if instance equal undefined. Inside it is instance equal new singleton. Argument option and then closing, then return instance, then closing. Then we define an object con singleton equals singleton tested dot get instance. So we use the dot get instance or the get method from that previous object we created. Inside this is we use point x key value point x key point x and then value 5, then closing, and then we log the output. So where is the point x came from? The point x came from the private singleton class that was defined before our instance holder and a con singleton's nestor object. So log the output of point x just to verify if it's correct. Output is 5. So as you can see, console.log singleton.x points to the same reference or the same instance. So here is how you would use this singleton pattern in practice. While the singleton has a valid uses, often we find ourselves needing it in JavaScript. It's a sign that we may need to evaluate our design. So, like if we are finding ourselves that we need this actually pattern in our app, counterintuitively, it means that we may need to evaluate the design. So unlike C++ or Java, where you have to define a class to create an object, JavaScript allows you to create objects directly. So like for JavaScript, this pattern is actually not as used, unlike with other languages such as C++ and Java, because they require you to define a class to create an object. While in JavaScript, it allows you to create an object directly because again, it's a prototype pattern language or functional programming language. So only when the ES modules and modules feature were added, that it actually became a blend of object-oriented programming. So first, what a singleton really is. A singleton is not a class with one object. That's the surface. The real definition, a singleton is a guarantee that only one shared instance of something exists across the whole program. So you're basically maintaining its invariance. Important, it's about the control of shared global object. Typical real uses, configuration, logging, database pool, cache, app environment. So you already understand correctly. Yes, those are the classic valid uses. Second, why C++ or Java need singleton classes instead of a singleton just object? Here's the part that the paragraph assumes you already know. In Java or C++, you cannot just freely create objects floating around. You must do this class logger, and then inside this create an object. Then logger log equal new logger object. Everything must come from a class. Now imagine a big program. Two different developers write logger A equal new logger object and then logger B equal new logger object. Now you accidentally have two loggers writing to the same file. So that causes file corruption, race condition, duplicated connections, memory problems. So language like Java solve it by forcing the class to prevent more than one instance. Another thing that what make JavaScript hard, aside from its type, or not support, aside aside from its non-type safety system, is that of this non-object, I would call non-object safety system, because you don't have, you can't privatize those objects. So you can create and then you can create object without a class. You can have two objects manipulating the same data at the same time, which will cause file corruption, race condition, duplicated correction, and memory problems, not in compile time, but in runtime. So the languages like Java solve it by forcing the class to prevent more than one instance. Classic Java singleton, so class logger. Inside this we have key value. Inside we have private static logger instance. I guess this is an object. Private static logger instance. It's a variable, and then private logger object. So or private constructor, and then inside still inside of this class is a public static logger get instance. Then inside is if instance is equal to null, then instance equal new logger, then return instance, then closing. Key idea: you literally block people from creating another object. This is why singleton is a class pattern in Java or C++. So the pattern is in another way of thinking about this is that a class of Java is a singleton pattern, inherently have the singleton pattern. Because of this, as you can see, we have created private constructor, public static logger get instance. So if instance equals to null, then instance equal new logger. So inherently, before you can actually use that object or create this object, another class in the system must not have instantiated the object. Otherwise, classes of Java inherently block you from this, unlike with JavaScript, where you can just create any object without a class. So the singleton pattern is not inherently designed for you to like to block that object, unless otherwise you specifically have designed it. So because the only way to control objects in those language is to control the class. So you cannot control the object's granularity. Just how another way of saying this is that is the advantage and disadvantages of JavaScript, is because JavaScript can execute things in granularity. That's also its biggest advantage, in that you cannot implement this singleton, or if you have implemented it, you evaluated this, you need to reevaluate the design, because in JavaScript those singleton were not actually useful, or it's hard to be useful by design, because unlike with Java or other or C++, the only way to control the objects is to control the class. So you need to control the upper, or the another way of saying is that like exchanging the global control in the local control in exchange of global control. Why JavaScript is fundamentally different? Here's the sentence the book is trying to tell you. JavaScript does not actually need a singleton class, because JavaScript does not require classes to create objects. You can just do const logger equal inside this log message function, and inside this const.log message, then closing, export default logger. So what it's saying, another way of saying this is that you don't actually need those singleton class that was inherently implemented in Java to create this singleton pattern. Instead, you can just create it from the object itself, which is actually the inherent bad things about the singleton pattern of in JavaScript, unless you're actually using it for the really actual global object, which is the database connection. like TypeScript, really connecting to the database. So that's already one instance. No one can actually create another one unless they manually copy it. So you already have a singleton. No pattern required, no constructor required, no private constructor, no get instance function. This is the important insight. In JavaScript, a module itself is already a singleton. So another way of saying is that since you're creating an object in a module, that module itself is already a singleton. No need for you to create a class to create that because Node or ESM caches imports. So import logger from .logger.js, every file importing this gets the same object. Another thing is that if you import this, remember it cache that. Like if it's already imported, the browser remembers that with relation to the JavaScript. Therefore, you don't actually have to like create a class to be able to use this singleton instance again, because it is inherently supported by the module in its import and with how the objects are able to create a singleton code in itself without a class. So why the book says reevaluate your design? Because many developers coming from Java do this. Class Dagger inside this static instance. So it's a variable and then constructor object inside the object. If logger.instance, return logger.instance. Then next time logger.instance equal this, then closing, then export default new logger. This is pointless in JavaScript. So when you're creating a class inside, a singleton inside the class in JavaScript, that's the point. That's actually what the reevaluate the design means. So you could have written export default log message and then console.log message, just like we had the example before. Simple, safer, clearer. So when JS developers implement a singleton class, it often means they are copying Java patterns without needing them. So you're creating a lot of overhead, while at the same time, you're creating like a nested, you're making harder for other modules to use the singleton because they actually need to call the class before like calling that object singleton. So why modern JS classes confuse you? You said it's newer JavaScript. We usually create object through class. Here's the critical realization. JavaScript classes are mostly syntax sugar. Like this class user inside this constructor, argument name, and then inside this dot name equal name closing is actually just function user argument name, and then inside this dot name equal name. So you don't actually need that class in the first place because JavaScript is again prototype or functional programming in the first place. And JavaScript can skip both and directly do const user equal name equal a key value name and Garrett string closing. So you can actually avoid this initialization of function and thus directly create a key value from a constant. So you don't need to create a class, a function, just need to create a constant to make your code readable. So unlike Java or C++, language C++, need class to create object, yes. Language Java, need class to create object, yes. Language JavaScript, need class to create object, no. That's the whole paragraph. The essence, this is what you're missing. Singleton exists to solve how do we safely share one global resource. In C++ or Java, it controls the class. In JavaScript, it controls the module. So The way we share global resource in JavaScript and Java is different. In Java, you control the class because you cannot create an object or a singleton without a class. In JavaScript, we control the module because we can create a singleton object inside the module directly. So modern Node apps naturally look like this. So db.js or db.ts, import mongoose from mongoose closing, then mongoose.connect argument process.env.db closing, then export default mongoose. So every file, import db from .db/.js closing, you now have a single database connection. You just implemented the singleton without writing a singleton pattern. Seventh, why singleton is sometimes a design smell in JS. Because often developers use it for user session, application state, business logic. Example bad, global user.js, export default, key value current user, and null with a value null closing. Now every part of your app secretly depends on global state. You get hidden coupling, impossible testing, race condition. So now your app may crash intermittently. It's impossible to test. You get race conditions, stale UI. So the book says if you think you need a singleton in JavaScript, pause. Often, you really need dependency injection, passing parameters, function, composition. So the issue is that the reason why you need to reevaluate your design is because singleton is mostly used only for few simple modules. You won't use that in business logic like this because you get those like runtime errors, stale condition, unnecessarily state leaks, unnecessary complexity, etc. So you often need like the dependency injection in the DB that we discussed, passing the parameters from another module, function composition. So you just need like to build like complex function built from the smaller function. The deep connection to everything you've been reading, this is actually connected to clean architecture, React state, backend service layers, microservices. Good systems, data flows explicitly. Bad systems, data lives in globals. Singleton is equal control global. So in good systems, since you mostly have those local state, like the user session, etc., you have those mini functions, so the data flows explicitly or more granularly. In bad systems, the data lives in global, so all of those application lives in global. Therefore, it's hard to test. You get the stale UI, etc. So in C++ or Java, it's a necessary tool to use like this singleton pattern. In JavaScript, often a warning sign. So final understanding, the paragraph means not singleton is obsolete, but JavaScript already gives you a module level single instances naturally. So implementing a formal singleton class usually means you're importing an OOP solution to a language that doesn't need it. You don't remove singletons. You realize JS modules themselves are the language built-in singleton mechanism. Thus, you can create one such object directly instead of defining a singleton class. In contrast, using singleton classes in JavaScript has some disadvantages. Identifying singletons can be difficult. If you're importing a large module, you will be unable to recognize that a particular class is a singleton. So let's say you're creating a module and then importing a lot of third-party module from it. You may not be able to realize that it's actually a singleton, so you may not be able to use the pattern of if-else. As a result, you may accidentally use it as a regular class to instantiate multiple objects and incorrectly update it instead. Second, challenging the test. Solutions can be more difficult to test due to issues ranging from hidden dependencies, difficulty creating multiple instances, difficulty in stubbing dependencies, and so on. So another thing is that when creating like a singleton pattern class with JavaScript, is that um, you get a lot of hidden dependencies or hidden imports from another imports from our imports that is not instantiated yet. So you get these tail UI bugs. So it's not really like being used in like a user session or normal application logic unless it's really a global state. So need for careful orchestration, and everyday use for singleton would be to store data that will be required across the global scope, such as user credentials or cookie that can be set once and consumed by multiple components. Implementing the correct execution order becomes essential so that data is always consumed after it becomes available and not the other way around. This may become challenging as the application grows in size and complexity. So, like using a singleton in JavaScript since it's already built in, another disadvantage of this is that you will need to develop like a good understanding of the initialization order uh, of your like complex application. So you would need to know which depends on which in order for you to be able to implement this pattern or class singleton pattern correctly, such as the cookie, where that what component depends on cookie and what and when. So you avoid this like stale bugs. State management in React. Developers using React or web development can rely on the global state through state management tools such as Redux or React Context instead of singleton. So instead of like creating like a singleton in React, you would just use like a Redux or React context to be able to implement this global values. So unlike singletons, these tools provide a read-only state rather than the mutable state. So again, singleton has a mutable properties, but this state or this third-party library actually do not allow to mutate it. So again, Redux is only like a version control. You can only create new version instead of mutating the previous one. Although the downsides to having a global state don't magically disappear by using these tools, we can at least ensure that global state is mutated the way we intended to because components cannot update it directly. So like the disadvantage really of a singleton is the global state. Like because that global state needs to like handle a lot of dependency or initialization order which becomes hard as the application become complex. Therefore, the inherent issue with singleton is the inherent issue with the global state. But that doesn't mean that global state is not necessary. In fact, it's actually being used in application because you need some global handler of the state. So the what Redux solve is that not that the disadvantage of that global state, which doesn't take away its advantages, but rather the stale or another bug or the bugs that you won't get because you're not now allowing to mutate it. So let's go to the prototype pattern. The GOF refers to the prototype pattern as one that creates objects based on a template of an existing object through cloning. So this is actually how the JavaScript works. So it's kind of like what do you call this? In AWS we have like a template. I forgot in database. I think what do you call this? Yeah. So in AWS we have CloudFormation templates. So it's a JSON or YAML files that act as a blueprint. So it's kind of like that. This prototype pattern. It creates object based on a template of an existing object through cloning. So it cloned that copy of it. So this is actually where that CloudFormation template came from. First, forget syntax. What problem is prototype solving? Prototype is about this, creating new objects by copying an existing object instead of constructing from scratch. But that's not the essence. The real essence is move object creation logic from classes to objects themselves. Because again, JavaScript is an object, um, isn't a more of an object type than a classes. So that's the shift. Second, why this mattered in C++ or Java again? Historical concept. In Java or C++, you must define a class. Objects are created by calling constructors. So, like in JavaScript, you can let's just call constructors. But here in Java, you would need to call constructor inside a class. Constructor logic lives in the class. So the logic lives inside the constructor and the class, because class is the grandfather. If creating an object is complicated, deep configuration, nested state, dynamic composition, you end up with massive constructors, factory classes, complex builder patterns. Prototype says instead of constructing a new object using a class, just copy an existing configured object. So, if you are creating the same object or class or constructor uh, every time you need it, therefore you're gonna have a lot of instances of that object, you will have to go to the process of initialization of the nested state. So it will take a lot of like resources. In prototype says instead of constructing a new object using a class, just copy an existing configured object. Example, Java style thinking. Instead of car equal new car object with v8 string comma red string comma letter, you do car2 equal car1 dot clone um, car1 dot clone object or constructor. So you basically equating the car2 to the clone constructor inside the car1 class. Now you get same configuration, same internal state structure with optional tweaks. Third, what thorough cloning really means. Cloning is not just copying properties. The deeper meaning, the object itself becomes the blueprint. Instead of blueprint to create object, you have existing object, duplicate to modify. So this is huge. philosophically, because then you avoid that like initialization and things like that. And then once you copy the prototype, just like we have with the constructor, that's the time we can modify it in our use case and then export it for other modules to use it. So you have existing object, duplicate it and modify. You don't have that blueprint to create an object concept. Now, so this is huge philosophically. It means no dependency on a constructor, no dependency on a class hierarchy. So you're not dependent on class hierarchy because you don't need to initialize all of those things because you just copy it. And then you're not dependent on those constructor because again you copy the object. No need to know internal creation details. So you don't need to be aware of how it is being created and what dependencies those constructors depend on. You can just copy that interface of that object, copy that whole object, and then create your own and mutate it. So you copy behavior plus structure plus state. So forth. Why is this especially interesting in JavaScript compared to Java? So here's the twist. JavaScript already prototype based. Objects inherit from other objects. Example, const_car prototype is equal inside is start function, inside is console.log string with an argument string engine started, then closing, then const_car1 equal object that create car prototype closing, then const_car2 is equal object that create car prototype closing. So we create the object from the same constant. So object. So we create another two object from that first base const or from that first base object. So you didn't use a class. You clone behavior via a prototype. So you didn't need to use a class or another overhead of use of class-based language. So JS is literally built around this idea. Classes in JS are just syntax sugar over prototypes. So prototype pattern in JavaScript is not really a pattern, it's how the language works. So what problem does prototype really solve? Here's the deeper systems level idea, aside from that being a language inherent advantage. Sometimes construction is expensive or complex. Examples, pre-configured database client, so let's say like you create like a large object for a database client that contacting database, a large configuration object. So again, this is kind of related as you see in Singleton. Game object with complex stats, div nested UI state, parse AST3. So instead of recomputing, you create a base configured object and cloned it, right? So like if this object, so the use case of this is that think about this like this. If you have like a complex base like that is imported from different things, then might as well just create this object already. So you don't need to instantiate this and object in other parts of your module. So this you will just base on this since you've already created this and then already cached in your browser using JavaScript. You can just copy it and then modify it and then use it in your use as abstraction on top of it to be able to apply it in your use case. So you create a base configured object and clone it like AWS CloudFormation, good analogy. You don't manually build every EC2 from scratch. You clone a template. That's prototype thinking. The deep principle, this is the real takeaway. Prototype shift this. Creation by instruction, creation by example. Instead of saying, here's how to build one, you say, here's one, make me another like this. So this is a huge philosophical shift in software design. It reduces coupling to constructors, because like copying that does not only, like, again, it's worth reiterating, making use of that already made object and not in having to initialize all these dependencies, but the mental ease that you get of not being aware of the implementation inside of that object, uh, when that could be the thing that you would do if that is reconstructed. So that's another thing that it removes. So it reduces coupling to constructors, coupling to class definitions, rigid inheritance trees. Seventh, how this relates to singleton. Now connecting it back, singleton control how many instances exist, prototype control how instances are created. Both are about object lifecycle management, but singleton equal restrict duplication, prototype equal controlled duplication. Opposite forces. 8. Hello? Hello? Yes? Ito ba yung loan or something na may interest yun? Anong meron dun? Bago ba yan? Hindi kasi na ano ko na yan eh, na may parang tatlo ata ng apat na tumawag sa akin na nagtabang about dun sa loan na pati yung autopay dun sa I mean yung autopay dun sa bills. Ano ba yung cash to go? Hmm. Wala kayong mga ano, parang mga iba pa. Kasi parang dun sa service. Ano ba yun? Okay, so let's go back. When prototype becomes powerful in modern systems, real modern example first React state cloning, const new state equal I don't know what this called dot on state. So basically, it's an object and then closing. You're cloning state instead of reconstructing it manually. So React actually does this prototyping because again it stems from JavaScript or cloning. Second, Redux reducers always return copies, not mutate originals. So prototype thinking as well. So it also used the prototype concept of JavaScript, and again it's written in JavaScript. Third, object pooling in game engines. Clone pre-built enemy template instead of constructing every property again. So the enemy in games are actually made from prototype engines. And again, JavaScript is written from C++ and games are written in C++. Fourth, database query templates. Clone base query and adjust filters. So in database, whenever you're copying something, table, and adjusting the filters, you're using the same concept of prototype. In the real essence, the part most books don't say, prototype exists because construction is sometimes more rigid than duplication, especially for large codes base, such as deep nested UI. What is other? But a pre-configured database client, a large like configuration object, etc. So classes define structure, prototypes define behavior sharing. So you define the behavior sharing instead of creating a class or a structure from scratch, right? So prototype pattern says that objects reproduce, not let classes manufacture. That's a big architectural mindset difference. So final distilled essence, Singleton teaches be careful with global shared instances. Prototype teaches sometimes copying an existing object is more flexible than building a new one from instructions. Instead of creating your code, instructing every single line of it, sometimes it's more flexible to just copy it. So in JavaScript, singleton is mostly handled by modules. Prototype is literally the language foundation. So the Gauss pattern sounds fancy, but in JS, you've been using it every time you do const new object equal open semi dot old object closing semicolon. So it's the same with React, or object that create argument base object and then closing. You were already thinking in prototypes. Let's see the other examples. The core sentence you should focus on: the prototype object is effectively used as a blueprint for each object the constructor creates. But this blueprint is not a class. So that's an object. That's the entire essence. First, what you think is happening, class mindset. We naturally imagine this class to produce objects, like a part factory mode, car class to car 1, car 2, car 3. That is a class-based inheritance, Java, C++, or C. The class exists first. Objects are instances of it. Second, what JavaScript is actually doing. JavaScript does not fundamentally work that way. Instead, it does this. Object to another object to another object. Objects inherit directly from other objects, not from classes. This is called prototypal inheritance. Very important. In JavaScript, objects don't come from blueprints. Objects come from other objects. So the blueprint is the class. I mean, the object didn't come from a class. The prototype is simply the object you copy behavior from. Third, what object that create method really means, or open and close parenthesis, the deep meaning. This line const your car equal object that create argument my car is not creating a new class instance. It literally means make a new object that uses my car as its parent. So it's more of like instead of creating instruction, like copy what my parent did. So another way of thinking of that is like in a tree structure, the one that use that the one that use or prototype or copy an object is the child. So it's not creating a new. It literally means make a new object that uses my car as its parent. Not copy, not duplicate, link internally. So your car to my car. So basically, you might think it's actually copy. Another misconception or more nuanced detail about this is that you literally not copy or duplicate it. You link it internally. So like your car to my car. If your car doesn't have property, JavaScript looks upward. Like console.your car.name. Your car has no name. So JS check its prototype my car and finds it. So that's just the language execution works. So basically you link it, since you link it to a prototype, so that's how it was linked and not copy, is that if your object doesn't have the property inside that you define, it will look to your parent that you copy for a value. So JavaScript inherently does that. That's why it's prototype-based language. So the prototype is a fallback object for behavior, not a template file, not a constructor plan, a delegation chain. This is the single most important idea. Fourth, why the book says there isn't a definition object. Because in Java, class definition will create an object. In JavaScript, existing object to new object. No formal definition required. You don't describe what an object should be. You point to another object and inherit from it. That's what the book says. We're simply creating copies of existing functional objects. But even copy is misleading. It is actually behavior sharing via delegation. Or it's more, I think more accurate way of saying is that inheriting a value from a parent. Fifth, why this gives performance boost. This part in the book, functions are created by reference. Example, wrong mental model, class thinking. You think every car has its own drive function. Reality, all cars shares one function. Like car 1.drive, car 2.drive, car 3.drive, same function in prototype. Because the function lives in the prototype object, so 10,000 objects do not create 10,000 functions. They all print to one. That's a huge memory advantage. 6. So that's the thing. That's the nuance on it, right? You don't see it in memory, but if you think about this that way, that those 10 objects now, since they share the same parent, or in this case function or the drive, you don't create 10,000 function, or you don't reconstruct it every time. You just share those behavior to each of those object or that drive function, since all cars shares that function. So they all point to one. That's a huge memory advantage. So then, why does class exist in modern JS? This is the sentences you didn't fully catch. Classes get compiled down to functions and prototypes internally. So then why does class exist in modern JS? This is the sentence you didn't fully catch. Classes gets compiled down to functions and prototypes internally, meaning class car inside this drive function, it's secretly converted by the engine to a constructor function, a prototype object, linked instances. So classes are a friendly illusion for programmers coming from Java. JavaScript did not become class-based, it only became class-looking. Underneath, it's still a prototype chain system. So it's this drive is still a constructor function. You can still use this without the class car. You can still link to it from another object in another module as long as you export it. It's still an object, a prototype object that you can copy. Like that's an inherent foundation. It's not a class. 7. What's differential inheritance means? This is actually a very important phrase. It means you don't copy everything. You only add what is different. Example, cons animal. So you, that's the differential inheritance is what we discussed earlier, in which we just add another thing that is different. If those objects are linked and some are different, you only change what's different and just use those parent function or the drive function um, instead of creating one yourself. So that's the differential inheritance means. For example, another example, const animal with the key value its uh, with the key its and then a value true, a boolean true, and then closing, and the next line const dog equal object that create argument is a parameter is animal, then next line dog that barks equal true, and then closing. Dog does not copy its, it inherits it. So it inherits the its from animal. So the new object stores only the differences. That's why it's called differential. 8. Now the real essence of the prototype pattern. Here it is. The prototype pattern is teaching delegation instead of classification. Class thinking, what category is this object? Prototype thinking, who does this object learn behavior from? In class OOP, you organize the world into types. In prototype OOP, you organize the world into relationships. This is totally different philosophy. 9th, connecting it back to singleton. Singleton controlled how many objects exist. Prototype controls how objects acquire behavior. Singleton limit creation. Prototype avoid rigid definitions. Singleton is about global state. Prototype is about code reuse without hierarchy. 10th, so without hierarchy or without instantiating all of those necessary imports of those the objects you want to copy or you want to inherit from. Why this matters in real development? This is the part most dev miss. Large inheritance trees cause fragile code. So if you inherit or you create a lot of object instead of just referencing that already exists, like you have multiple objects of the same like value, instead of using it, you have fragile code, time coupling, impossible refactors, and also hard to test. Prototype style instead enables composition, like building larger function. So that's actually composition. Another thing is that that's another way of explaining composition, right? Because it's building a bigger complex function from a smaller function. So prototype style instead enables extension, composition, plugin systems, middleware systems. Node or Express middleware is actually prototype philosophy. Each middleware doesn't subclass a server. It attaches behavior to an existing object. Like it share behavior to an existing object that if it didn't pass, depending on that value, how that value evaluates, it's just pass that to the next middleware. React hooks also follow this idea because again, those are based on JavaScript. Final distilled understanding. This chapter is secretly telling you Java, C++ worldview, objects are instances of classes. JavaScript worldview, objects are linked to other objects. And the prototype pattern is not really a pattern in JS, it is the native object model of the language itself. Classes in JavaScript are a convenience, prototypes are the reality. When this clicks, so the classes in JavaScript, you only do that for convenience, but in reality, it works as a prototype. So when this clicks, a lot of JavaScript architecture suddenly makes sense, especially frameworks. Let's go to another one. First is the prototype chain a tree data structure, close but not exactly. It's actually a linked chain, a directed acyclic graph in theory, but practically a chain, not a full tree. So it's not a tree that we discussed, like kind of like a tree. So let's redefine that mental model. So this directed acyclic graph in theory are what it is in theory, kind of like with Redux, because again Redux came from JavaScript. When you do const your car equal object that create argument my car, internally JavaScript stores a hidden pointer, like your car that prototype to my car, and my car itself point to another my car to object that prototype to now the actual value null. So lookup works like this. When you run your car.name, JS engine does first check your car, second not found, third follow prototype pointer my car, fourth not found, fifth follow pointer object that prototype, six stop at null. So this is like this another way of looking at it is that it's a there's a branch prediction, or like there's a like nested branch. It's the same with B-tree concept and with the object or with the column oriented database concept. So these are the same concept in which in column you execute it immediately, while here you get like a nested sheet or a nested pointer, like to get the actual value. So this is called delegation loop. Important, it's not a parent-child ownership tree, it's a fallback chain of responsibility, because it's not really a parent, in a sense that it actually owns that child, but they are just linked, and you're just trying to make use of their resources in order to avoid instantiating multiple copy of the same instance instead of reusing it. The object is basically saying, if I don't know how to do something, ask the object I learned from. So the real mental model is prototype equal behavior delegation, not hierarchy. Is the shared function like read-only OS memory sharing? This is an excellent intuition, and you're actually very close. You said like returning the same memory reference to a process. Yes, conceptually similar. When you define function user, and then next line user that prototype that log in equal the function that you initialize, then const u1 equal new user, and then const u2 equal new user. Memory actually looks like this: u1 and then u2, the same login user that prototype, or it's the same with the drive function connected to that 10,000 cars. So yeah, it actually the same with the read only with the OS. So JS does not copy the function,
into each object. They all reference one function object in memory. This is not OS read-only pages exactly, but principle is similar. Behavior is shared, state is local. Each object has its own state. Like you want that name, you do that name, but they share behavior. They share the name. You want that login is equal you to that login is will be equal to true. So the reason is efficiency. If 10,000 video participants join your live kit room, you don't want 10,000 copies of the same methods. Third, OOP organizes the world into types. What that really means. This is a philosophical difference. Plus OOP, Java thinking, we start with categories, user, doctor, patient, session. You define class patient extends user, then class doctor extends user. You are modeling what something is. That's type-based thinking. Prototype thinking, JavaScript natural model. Instead, you think, what behavior does this object need right now? You don't care about category as much as capability. Example, instead of doctor is a user, patient is a user, you might do can authenticate, can join room, can send message, can moderate. Objects gain behavior by linking or composing, not by classification. This is why GS frameworks rarely use deep inheritance trees. Another way of thinking about this is that, yeah, you're not classifying it or you're not classifying or modeling something as a category. You're basically asking what behavior. Another thing is that since this is the structure of the prototype, GIS basically really use the deep inheritance or like the uh, parent-child relationship that you would most likely or more inherently have to do in a class-based language. So where prototypes actually appear in real code, this is the part you were missing. You ask auth service. So you ask auth service database connection UI. Here's the surprising truth. You are already using prototypes everywhere in your app, even if you never wrote object.create. Example in your project, React components. Every React component function invitation form internally becomes an object with prototype methods, like invitation form that prototype. So that function are inherently related to some other shared related object. React elements inherent behavior from React's internal prototype system. Hooks. In your hooks, your use auth session.ts, use video call.ts, use waiting queue.ts. This returns objects. So in your hooks, your use session, use auth session.ts, use video call.ts, use waiting queue.ts. This returns objects. When React manages them, they rely on shared internal prototype methods from the React runtime. Okay, so the function that relates or that React that connects to this, if these objects are already created, or the backend, the hooks, the TypeScript. So React manages them internally. So if one object are already created, therefore React won't be able to um, won't instantiate that again, but rather reference that already existing object. So in Node or Next.js request objects, for example, your API routes, route.ts, receive, request, response, and headers. So these are not plain objects. They are instances of classes whose methods live on prototypes. So this route.ts has these three objects, which in turn related to shared behavior object that live on prototypes like rec, the request.json object, rec.headers.get, and res.status. Those functions are not inside each request. They live on a prototype shared by every request. That's why those route.ts, where your app routes, actually have this like deterministic behavior when you click the app and not like having stale behavior, because those are actually share the same behavior that makes the app globally synchronized. Firebase admin SDK, firebase-admin.ts. So the Firestar client you import is a singleton like instance. But its methods comes from a large prototype chain. So this Firebase admin.ts that you would import from a client in React is actually a singleton instance that has its methods, or like the method or logic in it are actually dependent on a shared behavior in a large prototype chain. For example, LiveKit SDK, your patient LiveKit room.tsx, RTC transfer.adapter.ts, LiveKit participants, trucks, rooms, all are prototype-based objects internally. Every participant share, connect, publish, truck, subscribe. One implementation, thousands of instances related to it. So even if you have like multiple participants, another way of saying is that they share the same connect, public, truck, and subscribe method or logic or state or object. So because each live participant's trucks has rooms, connect, publish, and subscribe. Where you would intentionally use prototype. You probably won't manually write object that create in most web apps, but you will design with the principle when first plug in systems, example chat message handlers. You create a base behavior. Message handler is the parent, and then the common behavior. So the image handler, file handler, transcription handler has the common behavior of message handler. They share behavior but extend capabilities. Second, middleware pipeline, very relevant to your app. Your middleware.ts, read-limit.ts, auth-util.ts, error.handler.ts. These conceptually follow prototype philosophy. Each handler doesn't subclass a server. It extends behavior of a request pipeline. So these share a lot of like common logic. Express and Next middleware are basically prototype chains and behavior. So the express chain, which we pass like an object and then validate it in each of that pass, is actually use prototype because they share the behavior from other component of the app, whether it's front end and back end. Third, real-time session objects, your LiveKit consultation session. This is where prototype thinking shines. A consultation session could have messaging behavior, presence tracking, recording, transcription. So a real-time session objects, for example, will have a lot of prototype like the consultation session because a session would have a messaging behavior, presence tracking, recording, transcription. Instead of a giant class, you attach capabilities. So instead of multiple instantiating a multiple objects and then instead of dynamically ordering it from scratch again, you share that shared capabilities. This is a prototype style architecture. The real essence you're supposed to learn: single thought control global shared state. Prototype is teaching shared behavior without forcing classification. Class OOP, identity first to behavior later. Prototype model, behavior first to identity optional. And JavaScript chose behavior sharing as its foundation because the web is dynamic. So it's by design, it is behavior first and the identity optional because it's being used in the web compared with Java before. It's being used by like a desktop application or a private application inside a private network. Objects gain and lose capabilities at runtime, very common in real-time apps like yours. So the again, JavaScript is a runtime, more of a runtime thing because those you like manage the dependency or like things change when the user interacts with your app. So basically, the objects related to the other object um, lose and gain capabilities at runtime. So final understanding, you almost never consciously say, I will implement the Golf prototype pattern today. Instead, the lesson is JavaScript architecture encourages composition, delegation, capability sharing. Your live kit teleconsultation app, sessions, participants, doctors, patient, chat, moderation actually fits prototype thinking better than class hierarchies. The chapter is basically trying to rewire your mental model from software equal taxonomy of types to software equal network of cooperating behaviors. And once that clicks, middleware, hooks, event emitters, and real-time systems suddenly make a lot more sense. So it will be a long time before we actually get to the factory factor, which is kind of related to the singleton we discussed earlier, but so be it. So the core essence: behavior is shared, state is local. We're close, but let's make it exact. The precise version: state equal per instance data, behavior equal functions that operate on that data. So an instance of an object and the data on that object is what the state is. And the behavior is the functions, again that's the keyword functions, that operate on that data on the object. Think of data and the instance, a combination of that is the state. Well, the function that is being applied to that data is actually the behavior that is being shared across the app by the prototype. Sharing behavior means sharing functions references, not copying them. Local state means each instance has its own data slots. So another misconception, you're not actually copying with prototype, you're referencing. Because if you're copying, you're basically creating multiple instances of the same thing, which actually link the states. Local state means each instance has its own data slots. So when we say local state is that each of the instance we create has a data slot available for the user to input data or for the system to put data from it. Uh, so that's different from a global state. So in JavaScript, prototype base, function user, argument name, inside this dot name equal name, then closing. So this is the state per instance. So this dot name equal to name inside the function is actually the state. And then next line, user dot prototype dot login equal function. Now this function is a shared behavior. Inside it is console dot log. Inside is $sign this dot name login, then closing. So as you can see, that's the difference with the state and the shared behavior. If you create 10,000 users, there are 10,000 name values. There is one login function in memory. That is what behavior is shared. State is local mechanically, means it's not philosophical. It is memory structure plus object model. Where your understanding is slightly hand wavy. You said, does it mean that the data is what makes the object becomes the state, but the behavior of login is the one that's shared, like the 10,000 video participant methods? This is mostly right, but here's the nuance you're missing. Important precision. State is not data in general. State is data that varies per instance and represents the current condition of that object. So it varies per instance because you actually need a combination of data and object instance at a specific point in time to create a state. And that data, a combination of that data in each different instance, what makes the state. For example, can authenticate, can join room, can send message, can moderate. These are not just data. They are capabilities derived from rules. There are two possibilities. Case A, these are stored as booleans like user that can moderate equal to, that is state. Case B, these are computed. User that can moderate function then return user that role equal admin. That is behavior. That distinction matters deeply. Third, the subtle concept you're missing, you're blending three different layers. First, JavaScript prototype system. Second, design patterns. Diosmani. Third, TypeScript type system. These are related but they solve different problems. Let's separate them. Fourth, what the constructor prototype pattern is really about. Diosmani's prototype or constructor pattern is about structuring objects so behavior is shared efficiently. It's primarily about memory efficiency, object relationship modeling, delegation. It is not primarily about state machines. Authorization logic, type safety, React patterns, those are different layers. Where you're slightly miscalibrated, you said the essence of all of this is to reduce complexity, close but incomplete. The deeper essence is separate identity state from capability and share capability via delegation. The word matters. Delegation. JavaScript does not copy behavior. It delegates up the prototype chain. When you call user.login function, JS does first look on user, second not found, look at user._proto_, third execute that function with this equal user. That's delegation, not inheritance in the classical sense. If you miss this distinction, advanced JS concept later will feel confusing. So this user.login function, it's another way of calling like the drive function from car, or that shared behavior. So that delegation, not inheritance, is the classic sense. If you don't understand that, you will miss the advanced concept. So 6 critical misunderstanding about TypeScript. Since TypeScript came from since TypeScript came from JavaScript, it lends to more of prototype thinking than class hierarchies. Very important correction: TypeScript does not change the JavaScript runtime model. Even if you write class user inside this login function, it compiles to user.prototype.login equal function. TypeScript adds static typing, adds compile time guarantees, does not change prototype delegation. So no, TypeScript apps are not 80 to 90% prototype thinking. They are 100% prototype at runtime, but developers mentally think in classes. This mismatch is subtle and can confuse people later. The real concept that connects all of this. Now we connect to your LiveKit example. When you wrote can authenticate, can join room, can send message, can moderate, you were modeling capabilities. There are 3 ways to model capabilities. First, as state flags, user.permissions equal key, key value, key can moderate, value to. Second, as behavior methods, user.can moderate function. Third, as external policy logic, policy engine that can moderate argument user. So these are the state flags, behavior methods, and external policy logic that you can model in each of your component. Prototype pattern is only concerned with the number 2, the behavior methods, where the methods live. But architecture is about deciding between 1, 2, and 3. That's a deeper design conversation than prototypes. Where you might struggle later, important, here are subtle misunderstandings that could block advanced understanding. First, thinking inheritance is about code reuse. It's about behavior specialization via delegation. Reuse is a side effect. Second, thinking state and behavior are just data versus functions. More precise, state equal mutable per instance memory. So again, that's the keyword. Data per instance, or mutable data per instance in memory, because it follows the concept of memory. Behavior equal reusable logic parameterized by this. So whenever you're using this, you're sharing behavior from another object that you have an access to, like inside the module. If you misparameterize by this, you miss half of JavaScript. Third, thinking patterns are language features. They are ways of organizing thinking around constraints. JavaScript constraint, everything is an object, objects delegate, functions are first class. So the patterns are basically working around those constraints for us to be able to handle complexity better. Fourth, thinking TypeScript changes object semantics. It doesn't. It only constrains them at compile time. 9. The deep essence, what you can say in an interview. If you want something crisp and teachable, in JavaScript, objects carry their own state, but they don't need their own copy of behavior. Behavior lives on the prototype and is shared through delegation. This gives memory efficient and models capability cleanly. Or deeper, the prototype pattern leverages JavaScript native delegation model to separate per instance identity from shared capability. So again, it's worth reiterating, the prototype pattern leverages the JavaScript function or native delegation model to separate per instance and a shared capability. Per instance state or a shared behavior. That's strong. So one important clarification, you ask how this relates to behavior pattern like middleware, etc. Middleware is not about prototypes. It's about composition, different pattern category. So the middleware inherently use prototype. That's not about it. It has a more like property. Like it also have this function composition because you can use prototype or you can share behavior without following function composition pattern, which could still make cause like still error in runtime or make the app complicated. Different pattern category. Prototype pattern is equal object delegation. Middleware equal behavior composition pipeline. So since behavior is also a function, so you can think of the middleware function composition or building smaller function to a complex function is like a behavior composition pipeline. So don't mix them. Final diagnosis of your understanding. You are correct on the high level idea. Applying patterns in real code. But you're not correct on blurring architectural linkers, mixing runtime model and type system, slightly imprecise about delegation versus copying, but you're not fundamentally wrong. You're at the stage where refinement matters. Where does the number 3 policy fit in design patterns? In constructor prototype pattern, if the constructor prototype pattern is about creational, how we build the object, then the policy is behavioral, how the object makes decisions. So as you can see, look, we use prototype to share behavior, like just like how middleware um, is about like just like how function composition is not equal to prototype because prototype is just a behavior or just behavior we can manipulate into our own app in order to like use a functionally literate or more structured behavior pattern. It's the same thing with this. The policy is more of a behavior pattern because we have like constructor, structural, and behavior pattern. So the policy is more related to behavior than a prototype pattern, though it uses a prototype inherently. It's just part of the property. Specifically, it usually maps to the strategy pattern. The concept, instead of user object knowing if it can moderate, you take that logic out of the user and put it into a separate policy object. So instead of like having the moderate method logic inside of the user, you take that out and make it a policy and attach it to whatever user um, or whatever role you want to attach it. The connection, the user is the state, the data, name, role, and the ID. So the data is the name that you would put in the object in user that becomes a state. Now the policy is the behavior. The rules admins can moderate are kind of like the prototype. You still use the prototype but more intelligently structure it into a different module. So this different module could be attached or not attached, unlike with the normal prototype in which you don't have this as much granularity in attaching the policy to a state or behavior to a state. Second, why is this different from a prototype? Think of it this way. Prototype method number 2, the logic is inside the object. Code, user that can moderate function. Analogy, you carry your own permit in your packet, you check it yourself. External policy number 3, the logic is outside the object. Code, security policy that check argument user, comma, moderate. Analogy, you walk up to a gatekeeper, the policy engine. The gatekeeper looks at your ID card, your state, and the gatekeeper decides if you can enter. Third, why would the developer do this? The why. You ask, where does that go? It usually goes into a service or a middleware. Developers move to number 3 policy when number 2 prototype becomes too messy. So this is also what is being done in a scalable architecture. Imagine you have 50 different permissions. Can edit, can delete, can view, can export. If you put all of those methods on the user.prototype, your user object becomes huge and fat and hard to know or to test, and easy to have like stale UI in runtime. Now another way of looking at it, prototype already solves the issue of like sharing behavior to multiple instances. But those like a pattern that you could not choose to use. If you didn't choose to use, you can just use it more granularly by entering the actual data into the object instance, which is the state flags. So now we're talking about the more scalable. For a small apps, small like first time apps for a beginner, you can definitely do that. But for a large app, you would do the number three. So how would this number three are being used actually in modern application? It usually goes into a service, services logic, or the middleware. Developers move to number three policy when it becomes magic. Imagine you have 50 different permission, can edit, can delete, can view, can export. If you put all of those as methods on the user.prototype, your user object becomes huge and fat. By using number three external policy, first, your user object stays skinny, just state. Second, your policy logic is all in one place, easy to change. Third, you can change the rules without ever touching the user class. Fourth, let's connect it to your live kit or video participants. The prototype way. Every participant has participant that can mutate others' method on their prototype. The policy way. You have room permission object. You ask it room permission that can participant, argument participant, comma mute underscore action. In the patterns world, prototype pattern is structural or creational. It's about the plumbing of JavaScript memory. Another way of saying of this is that prototype pattern could be a state flux, but they can also be a behavior, which is the creational pattern or constructor pattern, or they can also sometimes blend in the structural pattern on how we structure the memory or share the memory. So it's kind of related to decorator mixin and facade. So it's another way of like hiding complex implementation details to a simple interface. Policy or strategy pattern is behavioral. It's about the business rules of your app. Summary table for your OneNote approach. Number one, Boolean flag, pattern category, state, data, where's the logic inside the instance. Why use it? Simple, fast, but hard to update. Leave. Approach. Number two, prototype method, pattern category, creational or structural. Where is the logic? On the underscore proto underscore. Why use it? Memory efficient, shared behavior. Approach, external policy, pattern category, behavior, strategy. Where is the logic? In a separate service. Why use it? Keep objects clean, logic is easy to test. The short answer is no. Linked list is not a tree. While both are linked data structures that use nodes and pointers, they serve different purposes and have different structural roles. So linked, so we have need to refine their mental model. It might confuse people to think that link, just because it used node data structure under hood, it also used tree, but that's actually not the case. It can use an array, etc. But it still uses nodes and pointers data structure under hood. Think of it this way, linked list is a linear path, like a single file line, whereas a tree is a branching hierarchy, like a family tree or folder system. Key difference at glance, feature, structure, linked list, linear, one after another, tree, hierarchical, parent to child, feature, pointers, linked list, usually one, next, which is next, tree, for tree, multiple, left, right, or children. Feature star point, linked list head node. 3. Root node. Feature pathways, linked list only one path from start to finish. So it's kind of like the linked list already that we discussed in data structure and algorithm. You cannot actually go into the middle without traversing the path. In 3, multiple paths from the root to leaves. In 3, you have multiple routes to get to the child node, kind of like with the B tree. And the trees discussion we discussed. Why they are compared? It's easy to see why people get them confused. Technically, you could view a linked list as a very specialized, degenerate version of a tree, where every node has only one child. However, the difference in they differ in two fundamental rules. First, branching. In a linked list, a node can only point to one successor. In a tree, a node can have many children. Second, the goal. Linked lists are designed for sequential access, processing items in order. Trees are designed for hierarchical organization and fast searching, like a binary search tree. The math perspective. So another thing, yes, linked lists can be implemented using an array of nodes, though it is not the most common way to do it. There are two main ways to build a linked list. First, pointer-based implementation, which is common. This is the classic version you see in most textbooks. Each node is a separate object or struct created in the computer's heap memory using a pointer. So this is actually how linked list or JavaScript works under hood. Each of this node in that list is a separate object. So this is kind of like how the behavior being shared as well from different object or node in the list. It is created in the computer's heap memory instead of the stack using a pointer. So how it works? Nodes are scattered in memory. Link. The next part of the node is a direct memory address pointer. So the nodes, again, with the structure of node data structure, they can be scattered in the memory, unlike with arrays. Right? Link. The next part of the node is a direct memory address pointer to that node. Second, for arrays-based implementation, your question, in this version, you pre-allocate a single large array of records or structs. How it works, each element in the array represents a node. So each element in that array kind of represents an object when we use a pointer-based implementation, because each node of that is a separate object that points to another direct reference in the memory. So a link is just the integer index of another position in that same array. So a link, or how would you link that node to another node in that same array, or how do we relate that index to another index in that same array, is just the integer index of another position in that same array. So why use it? All languages use in languages that don't support pointers or dynamic memory allocation. So if you don't support pointers, you basically don't support that dynamic memory allocation, such as with old language and old OS. Like older versions of Fortran or BASIC performance, it can be faster in modern CPUs because keeping nodes in one array helps with cache locality and temporal because of spatial locality. Portability, since there are no memory addresses, the entire list can be easily saved to a file and reloaded later. So since you don't need to retrieve pointer after pointer after pointer, It can be easily saved and reloaded. Comparison at glance. Feature storage, pointer-based dynamic heap, array-based fixed pre-allocated array. Feature the link, pointer-based memory address, array-based array index. Feature memory layout, pointer-based scattered, array-based contiguous, all in one block. Let's just continue with this. So let's just explain some of this, how this heap actually works. So the heap dynamic memory allocation. In OSTEP, the heap is for large, long-lived data that developer manages. In C, via malloc. In JS, the garbage collector manages this for you. So what is here? All objects, every open and close semi-curly bracket, open and close square, the map and the set. Closures, this is huge for your app. If use transcription.ts as a function inside a function that remembers a variable, that variable is moved from the stack to the heap, so it doesn't die when the function finishes. Class instances, your Firebase admin instance or LiveKit room instances also lives in the heap. Strings, in V8, strings are almost always from the heap because they vary in size. From your repo, session-runtime-task.ts, Redux state, this entire tree lives in the heap. rtc-transport-adapter.ts, the actual adapter object and its internal buffers live in the heap. So what is the stack? In OSTEP, the stack is for function frames, local variables, and control flow. It is fast and managed automatically. What is here? Primitive values, local number, boolean, null and defined, pointers. This is the most important part. The stack does not hold your LiveKit room object. It just hold the pointer to that object in the heap that actually hold the object. It holds the addresses, the pointer to where that room is in the heap. Execution context. When use auth session.ts calls validate token, a new frame is pushed onto the stack. When the function returns, that frame is destroyed. So from your repo in summary-logic.ts, a local variable like const count equal 5 stays on the stack. So if that local variable is in the stack, the variable const room equals stays on the stack, but it's just a 64-bit number pointing to the heap. So this const room, it's like a declaration only, a pointer, and const count equal 5 are just in the stack. It's not actually the actual value. So the value or the actual object that hold most of the bytes are actually lives in heap. The code segment text. In OSTEP, this is the read-only part of memory where the instructions live. What it is here, the V8 engine itself, written in C++, and the compiled machine code of your functions. So what it is here, the V8 engine itself written in C++ and the compiled machine code of your functions. So it's like the bytecode. Yeah, so the bytecode that is compiled by AST. So that's what lives here. From your repo, when you run use videocall.ts or rtc-transport-adapter.ts, V8 compiles this into machine instructions that convert to be bytecode that being evaluated by runtime. So the nuance, your actual.ts files aren't in memory, only the JIT compiled binary instructions for functions like publish track or handle webhook sit in this executable memory space. So that's the runtime or JIT compiled binary that will be executed by the runtime, and that's where the read only or the compiled machine code or the code segment in the O step are